ever so slightly. That might not have even made a difference. Hello, chat. Um, it is one of the evenings of all time. It's currently, is it Friday today? I think it might actually be Friday today. Yes, it's technically Friday. Uh, it's exam day at the very least. In 6 days. So I am here to do some tiny bits of math. I don't know how long I'll stream for. I'm currently writing off a little problem here on the 2022 exam. There are a lot of exams to look at, and I've tended to notification from my phone. It was apparently the sentry mode on the car, my parents' car. Someone tried to open the back door on the driver's side. So very likely, um, someone was trying. My brother was probably trying to get into the car or something. And mom's phone was slightly too far away, so the car didn't open. Something like that. Regardless, where were we? Yes, today's Friday. It's currently uh, 9. Is it p.m.? It's 9 o'clock in the evening at the very least. Um, Today was an interesting day in such as I feel like I accomplished stuff whilst also like feeling like god damn there are so many more hours in the day where I could like properly looking, right? Um, so having to contend with that is a bit annoying. Um, I did eat 3 meals today. I did not skip breakfast, which that's good. Try to I'm sorry, you guys can probably. I have my window slightly open behind me because this apartment gets it's very hot in the summer. And, not having some sort of window open. Sometimes I have the fucking door open, just outside on the balcony thing. Um, but that feels like I feel a little bit watched, or like a little bit like someone could like too easily intrude on my space or something, right? So sometimes I close it. Regardless, um, yeah, it's been a day. I learned, or I gathered. Did I stream? No, I don't even remember. I think I streamed a tiny bit earlier today. All the days are a blur at this point. But anyway, here it is. So I gathered all the transportation equations for this course. And I asked ChatGPT to help me just compile all of the ones. Thought it would be more actually. Because originally when I asked about it to compile it, let's see here. It's this one. Yes, if we scroll all the way up here, I can actually check. Should be one here. This one, this one, this one, this one, this one. So wait, let me just check on my list here. Then there could be one missing from my list. Or they just the same equation. They might actually be the same equation. It would be this one, I think, not the thing. Give me 1 second. Open up here because I wrote them all down again here. So 2021 is this one, 2022, yes, this one here is this one here. 2308, which is this one. So this one, 23. So the original exam for the 23 year. That one seems to have one that wasn't on my list. So I'm gonna go check. Let's see, over 2023 original exam in 23. So this one. We just have a look. Yes, this one here. I haven't done. So we'll do that one now. Sure, let's do that one now. I've done all the other ones. I could keep it, right? Which, okay, yeah, that's why ChatGPT was a little confused about it. Because when he compiled the list originally, he missed out. First, he just wrote down three of them when I put that Letitia together. I was like, haven't you missed some? And then he added one. I was like, I can't find the last one. That's this one because this exam PDF has a different name. So when he looked through them originally, he found it, and then took the date, which it says up here. But since the exam name here is wrong, I assume that's why it got a little confused, which is very understandable, quite frankly. Regardless, I'm gonna quickly run through this one. I could. I wish there was a good way of me to stream my screen on my iPad. It's a little unfortunate. Yes. You guys can sort of see, right? Well, you can't see the particular time sheet. No, I'm gonna stay this way. Yeah. I'll make a nice overlay at some point. I did make a few overlays for the computer focus one and the iPad one, right? But it was 2 days ago, I think, where I was doing stream where the primary focus was going to be on my face cam, right? So I just made it big and made this layout. And I've kept it because I haven't wanted to set up my whole iPad screen share thing because it's quite annoying the way I have to do it at the moment with Zoom. I haven't found a better way of doing it. There gotta be a better way, even if my computer is not a Mac. I know there's a program that you can like pay for that help to like stream your screen, but I would like not to pay for it. I don't think it's a subscription service. It's just I don't need it that bad. Let's see here, 2023-06-02, I think it said. Yes. We just got there. 06-02, yes. So UT plus 2 times UX equal to 1. That's a little different from one of the other ones, but this is very similar to. I mean, they're all. You can do certain things too. I like mix them up a little, but ultimately, it's you always do the same procedure, and then sometimes there's a little trick or something you need to, be a little aware about. You can't be caught sleeping at the wheel, but fundamentally, it's not a super duper hard problem to solve, which is nice. Yeah, I think there are a couple, like the basics, like the Fourier method ones, both for diffusion and then for the Laplace equation, right? Which are on the easier side to solve, right? And then there's other ones where you're not on a limited area, right? So it uses different methods and such, and that's. And then there's the wave. Yeah, it's the wave equation, right? From D'Alembert's formula for differential problems. I want to say that's the case. Yes. Those are the primary ones, right? And then there's some operator things and stuff like that, right? Like here. The operator problems tend to be like show symmetry and things where you can. When I see the operator things, like my brain immediately goes towards doing like a double partial integration. Is it called that in English? Derivation by parts. That's what it's called. Yeah. So you like, oh look, this means 0 here because these things are symmetric in this way, whatever. I think it's actually this one, right? Symmetric. Yeah, so this version is literally just laugh. It's a typical exam question when it comes to these operators. We'll cross the top and get there. Regardless, now to the thing we're supposed to be doing. I've essentially devised these type of questions into like 4 steps, right? So the first, I always write them down explicitly because then my brain knows to do all the things. The steps are very, you know. So we write all the equations now. A of x of t is equal to the, well, in this case it's 2, which is the speed, not equation, but expression, right? So it's the one that is in front of u of x. We have right here. So it's a 2 in this case. So then I write a of x of t is equal to 2. And then we have the one that's on the other side of the equation, which I don't know if it has a name. It probably has a name, but I just name it f. And then I'm good, so I write x and t and end of u, because in one of them there was a u there. And it's worth remembering that it could be of u. And in this instance it is 1. And the last one, I usually name g of x, which is your, well, what's the English word for beginning condition? That's not the word. I'm sorry about the birds. G of x at my least. This is ex squared. Right, and that's the first step, just writing them all down, so you have them in front of you properly. And the second step is you take dx dt. We're essentially finding the characteristic equation for it. So dx dt is then equal to a of x of t, which in this instance is 2. And then we treat the derivative as a division, right? So we move that over, and then we take the integral of both sides. You guys can see what I'm doing, but you can imagine, or if you're trying to follow along, you will very much know when you take the integral of that thing. The integral of dx is equal to integral to the t, and then we let those things go out. So we get x, which is now dependent on t, then equal to, well, integral of 2t, or 2, which is 2t plus some constant c, because it's the what's it called? Why the fuck am I blanking on the word for it? The integral equation at the very least. The words are escaping me. Right, but in order to find that, we define, so let x of 0 be equal to s, which is essentially we are picking one of the characteristic equations that is on our timeline, and we pick let x is 0 be equal to s, and we plug that in to the expression we have. So 2 times 0 plus c says that c is then equal to s, and then we can get an expression where s is equal to here x minus 2t. This is very common. So you usually put a 2 in these equations, I've noticed. There's like 3 of them, I think, where that's the case, which is interesting. Now we have that expression. Now moving on to the third step, we write du. So now we have the thing we're actually going for, du dt, which is equal to f x of t of u, just being very good about it, being this is a 1 here. Now we do essentially the same thing, right? Where we then get u of x of t is then equal to, well, 1 times those are t. So t plus k of x, it can depend on some x. And then in here, in order to find the k, we utilize u of x of 0, which we know is g of x that we defined earlier, which is our initial condition. That might be the word. G of x, but this is g of x of 0, right? Which we know is g of s, which then taking the expression, which was e minus x squared, is now g of s squared. G of s squared. And g of s squared, since we have an expression for s, which we found just 2 lines above, this is then e to the power of wait, I need one more thing here, because g of s here is equal to 0 plus k x0 in this instance, right? So we're finding an expression for k. That's what we're doing here. Es squared, which plugging in the expression for s is then x minus 2t. That thing is squared. So now we have a value for k. So put in that k into the thing. And now we have u of x of t then equal to, so don't forget this expression here, t plus our value for k, which we just found was e to the power of minus x minus 2t, and that whole thing was squared. And that should then be the solution. And I'm going to check if that's the case. So let's see here, this guy here, and this is number 2, I think. Here. No, that's number 3. It was number 3. Bing, bam, boom, 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 boom. Which is this thing here, which is this thing here. Yes, t plus e to the power of x minus 2t squared. And I assume they're doing the exact same thing that I did here, and naming things a little differently and such, which is fine. That's not important. It's good, cool, and great. This question here, the same as the one I wrote down over here. It looks very, very similar, right? That's a small cylindrical pipe, radiant and line L. Okay, no, it's slightly, they're both diffusion equations, which you set up, and then you have they're both very much worth doing. You need to do some diffusions just to get comfortable with when they do diffusion versus when they do, or like concentration diffusion, right, versus heat diffusion. Because the heat equation and diffusion equation are the same equation, because heat diffuses, and in a similar way as like smoke concentration or concentration of other things, all are governed by the same equations. But the way you talk about them is a little different, right? Because if you have like a gas, and then you put like you tighten up the ends so no gas can flow through it, which is equivalent to like something being isolated, right, or being kept at a constant temperature and such and such, right? So that's what I was doing originally here. The 2022.3. There's a 4 there. That's just strange. Oh, it's this one. It's wrong year. Which was this one here. I was in the process of just writing down, all the equations written on the PDE. And I was just writing the conditions of it. So x is between 0 and 1. And t is bigger than here. And then we have our concentrate, right? Our fixed x's in the beginning here, right? So x of 0, t, and u of 1, t. They were both shut, right? Yeah, so they're both shut. So no Well, it's actually the Neumann conditions, then, right? Because there's no change in those endings, right? In those ends. I think that's how you should do that. Let me very quickly check. Okay, I shouldn't look. I should actually write down all the other stuff, but the last one isn't particularly hard. It's the heaviside function of the thing, right? So let me just read through the thing with no fixture. Yeah, it's the heaviside function. So u of x of t, let's call it this. How should I write this? It's q. I think it was q times the heaviside function of x minus 1/2. Be 1/2 minus x. I don't remember which way the heaviside function goes. I think that's. I mean, it's directionally correct. Okay, no, oh, it's thing from the book. Okay, over there. Give me 1 second, chat. I will be back very shortly. I also had a break. I had a Kit Kat. All right. Let me just see here. A lot of different things here. You can probably just take random. Probably should. That would be a really good idea. Just take random questions from the book. Here somewhere they should be. Number 7. This one. Here we go. Yes, it's a there's a condition. Wait of t of x. Yes, of x, of course. I wrote them of t, but it's the space variable, not the time variable. I really need to have a potion. A bit unfortunate timing. Yeah. I don't know. My stomach has been very upset over the last couple of days. And it's getting pretty late. I don't know. So I want to try to get to bed early today. I likely won't. I'll get distracted or something else. My apartment is pretty clean at this point. I got some trash and such earlier today, which is good. Last little 20-minute stream, maybe. I don't know. What do I do the thing here? I'm also noticing my the sleepiness is settling in a tiny amount. So I think I'm gonna be back tomorrow. I'm gonna go have a long shit, honestly, and then hopefully go to bed pretty early today. Right, I'll pop a melatonin. I'll go for a little walk. I'll pop a melatonin. I'll fucking sleep like a baby, hopefully. And then tomorrow I'll get up early. Do I want to go to the gym tomorrow? I really should. I think I would feel very good if I did. I don't remember when they open because I think the unmanned door is still broken. I don't know that, but I would imagine so. I'm gonna look that up. Probably. I'm gonna go for my little walk. I can just walk down there and check. I'll probably do that. Yeah, because I really wanted to go to the gym over the last couple of days, and I haven't gone. Right, I've been doing a lot of math and cleaning. Right, quite a lot of cleaning, which is fine. You know, cleaning has to be done, but it is also slightly annoying to spend your evenings cleaning stuff, right? But I think it's off. Regardless, I will very likely see you guys tomorrow. for another little stream. I like doing these streams; they're fun. I don't have any. I don't really put any requirement with myself to do them. Right there, you just do them because it's fun, and then it is what it is, right? So, thanks for watching. I'll see you guys around probably tomorrow.